All right, it is the top of the hour. I want to thank everybody for your time this morning or this afternoon, depending on where you are. My name is Chris Nevash. I'm the Senior Product Manager for Christian Hansen products at Gusmer. And I'd like to welcome Christian Hansen and this great presentation on yeast. So I would first like to introduce David Spector. Welcome, David.
Thank you, Chris. Hello, everyone. I'm not going to bore you with my own particular bio. You can look me up on LinkedIn if you're interested, but I do think it would be prudent to just give a brief overview of the history of Christian Hansen. So we've been making cultures for a very long time, over 145 years. And we started in the dairy business, going out to all the different dairies in Denmark to build up a bacteria and yeast bank. And so while we haven't been in the wine industry for nearly as long, making cultures is certainly our core competence. Next slide. So how did we enter the wine world? Well, in the 1980s, many universities and wineries were actually using bacteria slants. And it was said that you could not freeze dry Enococcus ini for reinoculation into barrels. But the folks at Christian Hansen, based on their dairy and bacteria experience, were able to do it. And for many years, Christian Hansen had the patent, and we were the only ones that were able to provide freeze-dried direct inoculation bacteria cultures to the market. And so that's how we entered the wine world. Since then, we have released a whole range of Enococcus ini strains and non-saccharomyces and Saccharomyces strains. Next slide. So, why do we want to manage fermentations? Obviously, environmental yeast and bacteria can conduct alcoholic fermentation. They can conduct malolactic fermentation, and some of the best wines in the world are made this way. But winemakers have different needs. Each site is unique. And if you want more control, if you want more consistency in your wine, then you can manage your fermentations through biological means. And we're going to talk a little bit about that today on the next slide. So what do we mean by manage your fermentations? Well, at Christian Hansen, we like to think about that in three different categories. We have our pre-alcoholic fermentation yeast range that has, Lachantia thermal tolerance, Pichia claveri. Then you have alcoholic fermentation, which is obviously conducted by Saccharomyces cerevisiae. We have a number of products in that category. And then finally, we have our lactic acid bacteria to conduct malolactic fermentation. Next slide. So today we are just focused in on that first half. This is a slide showing the traditional sequential inoculation practice in winemaking. We're going to focus in on our pre-alcoholic fermentation with our non-Saccharomyces yeast and the alcoholic fermentation with our Saccharomyces cerevisiae option. Our next webinar will be on Enococcus ini and mastering your malolactic fermentation. Next slide. And then I'll end before introducing my colleague, Anne-Claire, to just let you know that our distributor, Gusmer, a very close partner, has a ton of resources for their customers in North America. You can go to their website, you can go to their catalog, where you can get a ton of information on our products, from our non-Saccharomyces to our Saccharomyces to our Enococcus ini cultures. And now, Anne-Claire, if you want to take it away and give a little overview of our products.
Thank you, David. Yeah, Christian Hansen, we're very proud because we've been elected the most sustainable food ingredient company. That was 2 years ago, but last year we've still been ranked number 2, which is well, was resulting in many efforts from our side. This was from Corporate CNITS, which is an independent ranking agency. So we're still working on it because this is obvious a continuous process. Next slide, please. So nowadays, what are the challenges that set the scene in winemaking? First, you probably know because this is this makes the headlines of many of the magazines in winemaking. The climate change and the increased temperature are really affecting the winemaking, especially the freshness and the level of alcohol. So that's two topics that are really high in the agenda. Then the SO2. Consumers' demand for reduced sulfites is something very significant in most of the wine markets. But reducing sulfites is obviously challenging because of course you need to take care of the risk of too high oxygen and spoilage microorganisms that may proliferate. And another thing is that because of the climate change, the pH is rising and the sulfite efficiency is linked to the pH. So you need to add more sulfites to get the same efficiency if the pH is rising. So it's another issue that may raise. And there is an increased competition in the wine world, and that requires diversification and improved quality. So that are the various challenges we suggest yeah, to address in this agenda. Next slide, please. So an idea can be to adjust your winemaking with pre-fermentative yeast to meet the customer demand, especially in the frame of reducing sulfites or increasing freshness. Lorenzo will come back on that. And that can enable us to adapt to the warmer climate and to the increased competition. So with the non-saccharomyces, you can access to a palette of different features. They are particularly adapted to high sugar levels, so to the very early stage of vinification. And they will influence the wine due to their specific metabolisms, which is significantly different from Saccharomyces. Another consequence is protecting the must, because by using those non-Saccharomyces yeast, you can reduce or eliminate sulfites and rely on the bioprotection, especially during the early steps of winemaking. And then another aspect is to enrich your wine and to mimic a successful natural process where a lot of wild yeast can play a role, but some will be desirable, some will be unwanted. And here you can mimic a successful natural process with well designed or well selected strains that really enables to go in the right direction. So you can express the potential of your wine and bringing intensity. So I will leave the floor to my colleague Lorenzo that will drive you through the 3 process of fermentations.
Hello, everybody. Hello from Copenhagen, Denmark, where Christian Hansen has its headquarters, Hørsholm, 20 minutes north of Copenhagen. I'm working there since 4 years as an application manager in fermented beverages with a focus in wine. So my role is really like to screen and to look for the next best yeast, non-saccharomyces, saccharomyces, or bacteria for wine application. And today, as my colleague have said before, we're going to concentrate on the first part. So we're going to look at the pre-fermentation, as we call it, where we apply non-saccharomyces. We call it pre-fermentation because we reserve fermentation to the working horse of Saccharomyces to that extent. But pre-fermentation is very important, as Anne-Claire said, if you want to add complexity to the wine by doing it in a controlled way. So we're gonna concentrate on this side, and then on the alcoholic fermentation, and looking at the product that Christian Hansen has selected and launched over the years. It was probably very exciting to be in Christian Hansen before I came, because around 10, 15 years ago, my former colleagues, they identified that there was a need to shake the market for cultures for wine fermentation, in terms that the wine industry was probably seeing a certain of monopolization of standardized wine, where the next culture that would have come out would probably be yet another Saccharomyces. So they identified that there is much more to play with than Saccharomyces, and they identified needs that the winemakers were asking for, and they found the needs by selecting and screening for specific non-Saccharomyces. So they looked at screening a Saccharomyces culture that could provide extra flavors, could convert precursors, could give on its own like a metabolism that was flavor rich, and we ended up by selecting Epicia cluveri, which I'm going to touch in a moment. Then another of the needs was in the talk of global warming, where maybe some hot and warm climate wines are starting to suffer from the lack of acidity, that they need to restore some acidity balance. So there they ended up by selecting a Lachance thermotolerance. And finally, the need for some textural complexity in the wine, for some of the bolder red wines, for example. And there they looked specifically on a culture that could improve mouthfeel in the wine by selecting a Toolbox del Brookie. So I'm gonna touch all these cultures one by one. And yeah, you can see what they can do, how much they can do. And let's start with the oldest, the one that has been launched first as a single culture. So this one is Toolbox del Brookie, called as a commercial name Prelude. So again, launched in 2009 with strong feature in improving mouthfeel. So this culture, according to the metabolism, they can release manoproteins. Manoproteins are larger polysaccharides connected to proteins that can actually give a smoothness, a roundness to the sip of wine. Also, Prelude can add to flavor complexity, and this is a trait that encompasses all the non-Saccharomyces that we're gonna talk today. So flavor complexity by releasing esters, by releasing flavor precursors like thiols, or by releasing also terpenes. And finally, Prelude is very efficient to counteract the increasing VA. For example, when you have a stress Saccharomyces, or you have a problem with, yes, like an osmotic pressure that is maybe too much at the start of fermentation. So Prelude is very good in releasing polysaccharides called manoproteins. And this is linked to the effects of a strain-based feature that this Tourgulaspora delbrueckii strain releases these manoproteins throughout the growth while budding, so by creating new daughter cells, but also during autolysis. And these manoproteins, what they do, they confer a certain roundness. They increase the mouthfeel of your wine. If you can see here on the side, I hope that I just place this one on the side, but you can see here a fermentation done on a blend of Syrah and Marcellan. So a red wine where the polysaccharides have been quantified, and we had a Saccharomyces alone, Prelude put in pre-fermentation with a Saccharomyces for 2 days, and then one where we added for 4 days. So you see that this amount of polysaccharides constantly increases the more we give Prelude the chance to express itself. So it's very interesting, very interesting features. It also is very good to implantate itself and grow in mast when it's low temperature. So we're talking about cold settling, cold maceration. We can see here that the curve for Prelude is the highest one. So that means that cell count goes up when we are like at 12 degrees. And then when we bring it down to 5 degrees, the population stays there, stays constant. So it's very good as a cold tolerant strain. Another feature is that it is very good as an osmotolerant strain. So let's talk about must that have high sugar concentration to start with, 250 and top. So we can talk about also like must that are meant for sweet wines, where sometimes when we add the Saccharomyces to start with, this can react as in a negative way in terms of imparting or releasing some acetic acid as a response to osmotic stress, and as well releasing fatty acid. These fatty acids are quite important because these medium chain fatty acids, they can be then down the road quite toxic to malolactic bacteria. So by applying Prelude for a couple of days before you add the Saccharomyces, you can on one side decrease the volatile acidity, at the same time as well decrease this fatty acid content. And for the happiness of the vinification, retain malolactic bacteria vitality at the end of the day. As mentioned before, all these non-Saccharomyces will have an influence on the flavor complexity, and Prelude does it in a way to change, to just, maybe it's not the most flavor releasing strain, but it gives like it confers a certain complexity to especially red wines in terms of fruit notes, flowers, spices. You can see here that the dark blue bars represent a vinification with Prelude, and that this is being scored just higher. There is not a pinpoint on one, maybe one flavor or two flavor notes. It's a general complexity that is being increased. So we like to see Prelude as being a very versatile yeast in terms that it can be used for red and whites, again, to improve non-fruity complexity. The ability to release manoproteins can provide a rounder mouthfeel, can give aromatic complexity, as said before, and again, like because of the cold tolerance, can also protect during cold soaking. And we like talking about protection because we inoculate it at the inoculation rate. That means there are like cells of Tourgulaspora. They are present, they can survive cold temperature. That means they're taking space, they're starting to consume sugars, they're starting to consume nutrients. So that means that whatever else that is in your must or your juice has less to thrive on. So that's a bioprotection by occupation. And let's jump on the next non-Saccharomyces. So said maybe Prelude is, let's say, on a scale more neutral on effect of like giving flavor, a specific flavor to that extent. Is more like flavor complexity. We have Viniflora FrootZen that is almost the opposite in terms that is extremely flavor active, and that relies on the enzymatic machinery that this strain comes with. It's very good in releasing thiol precursors, so sulfur-containing molecules that are bound in the juice, and they need to be liberated to become flavor active. So this strain can release them very efficiently, and on top of it releases also a whole array of esters. The peculiarity of this yeast is that, well, it was the first frozen yeast to be launched for in the wine industry, and by doing that is also a yeast that is suited for direct inoculation. So it means it's not gone through a drying process. It means this yeast, once that you launch it in a tank or you're applying after you thaw it, for example, here on grapes and harvested grapes, once that is dissolved in this juice, can start to act straight away. So it doesn't need to rehydrate. And more, this yeast is being used also for bioprotection purposes. So by being that fast in action, by having some peculiarities like loving oxygen when it's present, and some other features makes it a very interesting bioprotective strain. This is how it looks like. So it's being packed as a frozen block to that extent. You can take this block out maybe 15 minutes before you want to inoculate the tank. You need to cut the plastic off, and then you can basically let it drop in the fermenter. And you can see it there floating. Another way to do it is you can leave more time, like 1.5 hours or 2 hours at room temperature. This yeast will liquefy, will thaw completely, and then it can be added as a liquid to the tank. And again, as mentioned, bioprotection. So this yeast is being used for more and more for bioprotection purposes. And the fact that it's a Crabtree negative yeast means that when you have oxygen present, when you have high sugar present, this yeast loves them both. So it will go for the oxygen and will go for the sugars. We'll do basically a sort of a respiration to that extent, or a aerobic fermentation. So it will start to deplete oxygen present in your mass, and to that extent can almost partially replace an activity that sulfites would do as an antioxidant. This is an example of a winemaker that's decided to apply FrootZen after, like, post-harvesting for this dosage, for basically giving the most of time for the FrootZen to actually being active on the grapes. So what it does is that this FrootZen will sit on the berries, will start to work there with the leaching sugars of grapes that have been disrupted, and then it will start acting already. So once that you are like at the cellar, then you can you already had an action of FrootZen for a couple of hours before. And this is a result of such an application where FrootZen has been used in a unsulfitated Grenache Gris in France, and has been inoculated at a harvesting machine and then after pressing. And we see here that we run amplicon sequencing, and we see here actually FrootZen. So we looked at the fungal population, and after fermentation, after malolactic fermentation, we looked at what kind of yeast and fungi were still available there. And we see here that the vast majority is actually Saccharomyces yeast. That means that well, FrootZen has allowed as well the Saccharomyces as a good symbiosis with Saccharomyces. Whereas we tried two other competing non-Saccharomyces for bioprotection. And we see here that we have like a little bit more of a, let's say, unclean fermentation that took place. Again, here we have the juices, or like the wines from this fermentation, and we see here that in this other two fermentation, these other two tanks, actually it looks like there has been a little bit more oxidation taking place.
Lorenzo, we have a question about the SO2 addition. When you are using FrootZen, perhaps to reduce the risk of spoilage microorganisms or to reduce oxidation, as a winemaker, would you be using less SO2 or a similar SO2 regimen as you would without FrootZen?
Well, we had a little bit of everything. So FrootZen, and we are pushing, especially in France, for a regime where the winemaker can start to reduce SO2. So the no SO2 needs to be driven quite well, but more and more we have customers that they do just like to reduce some of the SO2. So it combines very well by having some of this natural bioprotective or antioxidative effect of FrootZen, and then a complementary reduced SO2 effect.
Okay, thank you very much. And will you be touching how we can reduce SO2 by increasing the lactic acid, by decreasing the pH, using Lachantia thermotolerance as well?
Yeah, I will come to that. Absolutely. Absolutely, we do that. Good point. Let me finish on FrootZen. So FrootZen, again, like talked about flavor. If you are dealing with, and especially application of FrootZen goes direction whites and rosé. In red has been tried much less. You can expect like blackcurrant notes, but in white and rosé, it really expresses some varietal character. And Sauvignon Blanc, so FrootZen has been originally isolated from a work done on Sauvignon Blanc in New Zealand that wanted to answer to the question, what actually gives that tropical, that tutti frutti notes on these wines. And it seems that the natural microbiota, composed also by picochloride, plays a major role into that. And especially these mercaptans, so these sulfur-containing molecules, they can be significantly enriched if you add FrootZen. So we see here Saccharomyces only fermentation, but if we add FrootZen, we can add it in co-inoculation, and we can add it in sequential inoculation. We can increase this content significantly. Again, FrootZen is not a strong fermenter. So our application involves that you leave it 1, maximum 2 days alone in the fermenter. It won't produce a lot of ethanol in the meantime. So you need to add then the Saccharomyces promptly. And then again, as well, FrootZen can release a copious amount of flavor intensive esters. So the strength is for sure boosting the fruit aroma. Sometimes winemakers also say like, that's almost a little bit too much that we get out of the flavor. But then they use these tanks also as a blending material. And especially for low aromatic grapes, like Pinot Gris, Pinot Blanc, sometimes Chardonnay, Trebbiano, FrootZen can really give the kick and can lift the aromatic value of these wines. And again, there is also like this bioprotection part that plays a role when you use FrootZen. Let's come to the last two products, which are coming from the same species, is Lachantia thermotolerance. Concerto is the one that we launched earlier, launched already in 2012. Concerto, or in general, the species of Lachantia thermotolerance, are known to produce or to reserve some of the sugar for acid production. So what it does is that it converts some of the glucose and fructose into lactic acid. By doing that, there is less of the sugar available for producing ethanol. So sometimes, depending on the fermentation condition, you can also see that there is a slight reduction of the ethanol content in the final wine. And then Concerto specifically releases fruity esters and yes, reminiscent of red fruits. By releasing lactic acid in an environment where ethanol is present, these two molecules actually compound. They can come together and form a bind and producing ethyl lactate. And this is chemically almost spontaneously happening in the must, in the juice, in the wine at the end. And ethyl lactate is a flavor compound that's reminiscent of can be strawberry, but also like some coconuts, a little bit of this creamy sensation. And you can see that if you add Concerto in this kind of wine, you can increase this this flavor as a final note. When the conditions are right, Concerto can do something else and can touch the final ethanol content. Again, it comes down to the fact that if the conditions are right, Concerto can produce more lactic acids. And by doing that, the ethanol content eventually goes down. So by having more acidity and having less alcohol, the wine comes just crispier, comes through as being more fresh. And we see here a couple of examples. This one in Bulgaria and this one in Australia. Actually, we see that Concerto can decrease significantly the ethanol content. Now, it's not always a given, but it's a nice side effect when you use Concerto, absolutely, if you look into that. And application can be optimized if you look into that kind of effect. Again, as David mentioned before, because Concerto and La Chance Tomatorans releases an acid, that means that you're going to touch the total acidity and at the same time the pH of your wine. By decreasing the pH of your wine, you are causing a side effect that is wished in terms of you can make your sulfites more effective, because the molecular form of sulfite, of the free sulfite, is the most effective antibacterially, antioxidantally. So that means that if you can reduce some of the pH, you also need to add less sulfites in your wine to make it to get the same strength from your sulfite addition. So it's a very nice side effect, but in general, Concerto is there to increase the freshness, clearly, to this lactic acid production, but also by releasing certain flavor compounds, by decreasing a little bit of the ethanol, and exactly can help in producing wine without or at least reduced sulfites. And it works very well for those red wines that are coming from warm and hot climates that maybe are suffering from the fact that, well, the acidity is being is somewhat down, that too alcoholic after fermentation. Maybe they have some jammy flavor. So Concerto is really well like the yeast to go for.
Lorenzo, before we move on to the next strain, we did have a question on FrootZen. The question was, how much CO2 is produced by FrootZen, and will it inhibit cold settling? Can you use it during stabulation or the juice settling phase?
Yes. So CO2 production is not copious. Absolutely, it's not. You don't expect. You almost feel like nothing is happening in your tank apart when you're then getting a really like a smell of it, and then you figure it out. Well, there is like a lot of fruitiness and tropical flavors coming through. So it's definitely as well being is also suited for stabulation, cold settling. You can apply it again. FrootZen is the yeast that is quite versatile. It can apply it at different stages. So you can apply it after harvest. You can apply it at cold settling. You can apply it also as after clarification, before, like, let's say, as a pre-inoculation, maybe one day before you inoculate Saccharomyces. So yes, that's all possible.
And just to provide a visual, to give you an idea of the application of FrootZen, I've been in many wineries where FrootZen has been added to a tank, and you will actually see a film produced at the top of the tank where most of the oxygen is almost in a floor type of style.
Exactly. Produces these isolates. So it is a yeast that loves the oxygen if it's present. So that's why it kind of like buoyant up to the surface, and often is there where you find FrootZen. And if you don't mix, you probably don't find it in the tank. But that's enough, really, like to get the flavor expression that you're looking for. Let me come to the last, let's say, pure non-saccharomyces product that we have, and this one has been launched very recently, last year in the Northern Hemisphere. It's called Octave. Again, we chose a musical theme throughout all our product range. It's again a Lachanza thermotolerance, but compared to Concerto, Octave is, let's say, the cousin on steroids almost. It's been selected for being more efficient in producing lactic acid. We see the application most suited for white and rosé. And there I have a slide where I'm gonna explain how, because now with two Lachanza in our portfolio, we decided somewhat to split the application for both of them, where we find it most suitable. So again, because it produces a lot of lactic acid, decreases more of the pH, and again we have those side effects on making the sulfites more efficient, and at the same time, I mean, you're producing natural acidity. That means that as a winemaker, you don't need to rely to let's say a lot of chemical addition of tartaric acid or other acid that you would add on. Also, lactic acid is a nice feature that is a stable acid, is chemically and microbiologically stable. That means it's almost non-consumed by any microbes that you would find in wine, and then chemically it reacts sporadically with any other molecules that you would find in wine. We've seen before this ethyl lactate, but we are talking about milligram per liter. Is nothing that would really affect the lactic acid concentration. So for that is almost the acid to go, because we know that clearly tartaric, citric, and malic acid, they can be metabolized, or they are physically unstable in wine. And well, Octave for application of white and rosé, we found out that it releases specifically like and quite on the point white stone fruits. Think about the peach flavor. That's pretty much the flavor encompassing Octave, plus all the complexity going around. But yeah, as I mentioned before, when we compared Concerto and Octave, we see that Octave can produce more lactic acid, and it does so mostly when you apply these two products. They do produce most of the lactic acid within the first 3 to 5 days of application. And this is because it's still a non-saccharomyces. They still have a maximal amount of ethanol that they can withstand. And when that is surpassed by applying Saccharomyces, for example, then they also will go down in vitality. So that's why lactic acid is normally produced at the very beginning of fermentation. Clearly, through choosing a protocol, application protocol, together with the Saccharomyces, you can decide how much lactic acid you want in your final wine. It's not always such a precise science, but clearly, if you leave more time for the octave to stay there alone before you inoculate the Saccharomyces afterwards, you will also get more lactic acid in your final wine. You can see it here in this curve that the octave has been left 3 days alone, and you see that lactic acid just ramps up. Whereas if you're applying only for 1 day before you apply Saccharomyces, you see that the lactic acid starts to find a final value. Again, touching the topic about ethanol reduction is not something that we push as a unique, let's say, selling point of this strain, because we find that according to the fermentation, how that is being done, according to the substrate, we can find quite different amount of ethanol reduction in the wine. But in general, when you use octave, you can expect an average of 0.4% unit based on the volume of reduction of reduced ethanol. Here we touch some of the sensory profile of octave. So again, this was done in a white wine from Sicily. We see that octave pops up with minerality, with some flowers, but especially in the taste comes through as being acidic. Clearly with acidity also comes a little bit of bitterness. This balance is being increased, and this salivating finish, which corresponds to a way of like describing drinkability. Let's say what pushes the consumer to have another drink of the same wine. So it's scoring quite high, and winemakers around the world has also described octave when being added as, again, like being quite peachy, thirst quenching. Again, you need to expect acidity helping the freshness, the crispiness of these wines, and just basically delivering a fresh wine.
Lorenzo, we have a question on Octave and FrootZen. The question is, are Octave and FrootZen compatible with bentonite?
Oh yeah, good question. That's something that I need to ask my technical salespeople. Maybe David, you can add something to it.
Sure. I think it depends a little bit on when the bentonite is being used. Oftentimes Octave and FrootZen are included during perhaps a cold soak very early on in the processing. So perhaps the person who asked the question can give a little bit more information on when they're using the bentonite to see if there would be some interaction between the yeast and the bentonite. But we can follow up.
I will carry on and expect for the clarification. Yeah, something that we find by releasing copious amount of lactic acid is that lactic acid has an inhibitory effect on malolactic bacteria. So malolactic bacteria are producing lactic acid through the consumption of malic acid. But if lactic acid is already present in a wine where they're being inoculated, this can slow down the activity. And we found out that above, let's say, a level of around 3 grams per liter of lactic acid really starts to affect this lag phase for malolactic fermentation to happen. So this, we can use it also to our benefit, in terms that there are clearly white wines, especially in warm and hot climates, that do not want to go through spontaneous malolactic fermentation. And by applying Octave, we're seeing that actually we can start to control the spontaneous malolactic fermentation happening during alcoholic fermentation, because releases exactly this copious amount of lactic acid at the beginning of fermentation. So here, for example, we have a wine that is being fermented in a hot climate, Grillo in Sicily again. We see here in a control tank where we didn't apply Octave, so only Saccharomyces. And we see that after alcoholic fermentation, the malic acid has gone away, and the lactic acid has ramped up. So a clear sign that malolactic fermentation has taken place. When we apply Octave for 1 or 3 days before Saccharomyces, we see here that actually, while we release the malic acid, we also produce lactic acid from the sugars. So what we do in these wines, we actually increase the total acidity of the wines. And clearly this can be very relevant for especially wineries that have an issue with regularly occurring spontaneous malolactic fermentation. But that's also the reason why, to a certain extent, we identify Octave to be most suited for rosé and white wines, because of this inhibition of malolactic fermentation, but also because the flavor activity is actually more suited to these styles. Concerto is still la prima donna for red wines, because the flavors that they're releasing just blend very well in these styles. But Octave can, in certain cases, also be used. Remember again here, malolactic fermentation can eventually be done as a co-inoculation approach. And yeah, sorry.
Lorenzo, with Christian Hansen having the widest range of non-saccharomyces yeast, for pure cultures and a number of blends, the Lechanso thermal tolerance, we often talk about how it can promote acidity, reducing pH, which might be quite good for warm climate regions. But we also have many customers in cool climate regions, and today we have someone asking a question from Minnesota, a winemaker from Minnesota. I know that we spoke about Prelude potentially being very good in high osmotic pressure wines like ice wines in Canada. But the question from Drew is, hi, I'm a Minnesota winemaker working with cold climate, high acid grape varieties. Do we have any non-sacc yeast that can reduce acidity or increase pH? Or is that going to be tools that winemakers will have to use bacteria strains to help them in increasing pH and reducing acidity?
Yes. So the short answer is, yeah, we don't have non-saccharomyces to reduce acidity. You can create an effect of increased sweetness by, for example, applying a FrootZen that will give you more of those like luscious fruits that might be counteracting the high acidity. But to that extent, I would lean on our bacterial range. Maybe it's suited for a late co-inoculation. But yes, short answer, no, we don't have a non-saccharomyces for that.
Okay, thank you.
And well, we do have not only non-saccharomyces, we also have 2 saccharomyces that we're commercializing. They're called Merit and Jazz. They are working in a similar way, but so they're both like copious amount of glycerol, robust alcohol fermentation, fast in fermentation, but at the same time, they do have quite a different note expression to it. So Merit maybe being the one that we would recommend for like bolder wines, adapt for aging, whereas Jazz, which is our strains that is being launched as well as a active dry yeast for direct inoculation. Well, there we do reserve Jazz for more like fresh, young, and fruity wines. But then something that we also specialized, actually something that we started all our history of non-saccharomyces is with blends. And let me introduce one of these, Melody. This is a blend of 1 Saccharomyces of ours with 2 non-Saccharomyces in in a certain specific ratio. So why this? Well, about thinking being the closest to a spontaneous fermentation, but a controlled spontaneous fermentation. These blends are very powerful because on one side they clearly encompasses the best world of non-Saccharomyces, Saccharomyces in one. They save preparation time. In fact, that you don't need to do inoculation of Saccharomyces after your pre-fermentation. It gives a complexity to start with. It's normally like a first step into the world of non-Saccharomyces, just to understand how powerful non-Saccharomyces can be. Then normally the second step is to work with different ratios that the winemaker wants to achieve by using the single pure strains as I just presented. But a very good first step and also a good cost in use is using one of these blends. And Christian Hansen and Gusmer, we offer different blends for it. Actually, exactly, Melody was the first non-Saccharomyces product that we came in commerce. And think about added complexity because we have Prelude there. So again, we have mouthfeel and secondary flavors. We have Concerto for adding some of the acidity, some of these like red, fresh berries. And exactly, that's a world that can be started to be discovered by using blends at a different ratio. So we have these 3 blends that Gusmer is commercializing. And here I come to basically a summary of what I just discussed, where we put together some of the parameters of use of these non-Saccharomyces in pure cultures. So the temperature, the sulfite tolerance, crush, the maximal amount of ethanol that can subsist, some of the features and description, but there is a lot of material, a lot of description on these products if you go on the Christian Hansen or Gusmer website. Again, FrootZen is the product that comes as a frozen block. So something to be kept in mind is that the logistics for this yeast is done at minus 45 degrees. So to that extent, there's also like to be the possibility of storing this yeast or at this temperature on the wineries. But we have also ways to let it come at a very, very kind of timed, suitable time for inoculation. And here we have the blends, and here the 2 Saccharomyces that we just discussed. And I think that's pretty much it for my parts. I don't know, David or Chris, if you want to take the word.
Thank you very much, Lorenzo. Appreciate you and Claire taking us through the Christian Hansen yeast range. We do have another question about FrootZen. Now, FrootZen is certainly getting the most love today. I think it is quite a unique strain. And Patricia asked, when using FrootZen in white wine production, should it be added pre or post settling? Settling with bentonite or an enzyme?
It can be added at both times. So again, we have there are ways also of, for example, some chitosanes that are used for flotations. They do have, they can have an influence on the population of non-saccharomyces by basically taking it away to that extent by separating it. But it depends how much time do you also give to your strain to work. I think whatever like can happen after post harvest, that's a nice place to start as well to apply FrootZen, because you are also ready to inoculate Saccharomyces much earlier once that you're like in the cellar. Again, we need to consider FrootZen is not a strong fermenter, so even though you want to leave some time for it to be applied, but then you want soon to apply Saccharomyces to build up that ethanol that can be basically protect your wine to that extent. Yeah.
Yeah, I think it does depend on what your goals are. If it's solely a bioprotective purpose, then I see many wineries adding FrootZen very early on before clarification, even as early as in the grape bins. We see many winemakers in New Zealand where this particular strain was isolated, actually trying to reduce the amount of SO2 that they're adding into the grape bins, and they're putting FrootZen there. But if you're looking to maximize perhaps the aromatics, then I think you should probably be using FrootZen in clarified juice, so after the cold settling process. So it definitely depends on what you're hoping to achieve in your wine. We also have another question. Can you discuss the nutrient requirements for these yeasts? How much nitrogen will they consume during their 1 to 3 days before that Saccharomyces cerevisiae is added?
Yeah, so for the non-Saccharomyces, we do recommend to have a look clearly at the total YAM to start with, and we recommend a range of 200 to 250 ppm, because depending on strain to strain, but it might be that they're using the same nutrients that the Saccharomyces then are gonna need. So what we also recommend is that at the time the Saccharomyces is being inoculated, after this, let's say 3 days of pre-fermentation, that there is a further addition of nutrients, of a mixture of organic and inorganic nitrogen. The only exception is FrootZen. FrootZen does not consume a lot of nitrogen. So that's good news, because again, it produces a lot of flavor for little nutrients, for little sugar, for little nitrogen. So that could be the exception to the bunch of non-Saccharomyces.
Okay, well, thank you so much, Lorenzo. Thank you so much, and Claire, and thank you, Gusmer, for allowing us to present on the Viniflora range. And most importantly, thank you all to the winemakers, the grape growers out there who took the time out of their day to listen to this presentation. I know there's a few more questions that we haven't been able to answer, but we do need to end this presentation on time. But I've documented those questions, and I will work with Gusmer to get the answers for you. But please reach out to your technical service rep, reach out to your Gusmer representative, and they will provide all the information and products and technical support that you need.
Yes, thank you everybody for joining. All these products are available through Gusmer, including the Octave that was presented. So thank you, everybody. Thank you, Lorenzo, David, and Anne-Claire. Appreciate you as always. Thanks for being a great team member.
Thank you. Have a good day, everyone.
Thank you, Chris.
Thanks,
you very
everybody.
much.